According to National Electrical Code Section 250.24 C7, a separate grounding electrode conductor is not required for a generator if specific conditions are satisfied. These conditions relate to how the generator is connected to the premises wiring system. Firstly, the generator must be connected to the premises wiring system through a transfer switch. Secondly, the grounding electrode conductor for the premises wiring system must be connected to the grounding electrode for the generator. If both of these conditions are met, then an additional, separate grounding electrode conductor for the generator is not necessary. Let's break down each of these conditions to ensure a clear understanding. The first condition, the generator being connected through a transfer switch, is crucial for safety and proper operation. A transfer switch is a device that allows you to switch between the normal power source, which is typically the utility grid, and the generator as a backup power source. This switch prevents backfeeding, which is a dangerous situation where the generator sends power back into the utility grid. Backfeeding can energize utility lines, posing a significant risk to utility workers and potentially damaging equipment. There are two main types of transfer switches: automatic and manual. An automatic transfer switch, or AT, automatically detects a power outage from the utility and starts the generator, then switches the electrical load to the generator. When utility power is restored, the ATS automatically switches the load back to the utility and shuts down the generator after a cool-down period. A manual transfer switch requires someone to manually switch the load from the utility to the generator. This typically involves flipping a switch or moving a lever. Manual transfer switches are less expensive than automatic transfer switches but require human intervention during a power outage. Regardless of whether the transfer switch is automatic or manual, its primary function is to isolate the generator from the utility grid when the generator is in use and to prevent backfeeding. The second condition requires that the grounding electrode conductor for the premises wiring system be connected to the grounding electrode for the generator. This ensures that the generator and the premises wiring system share a common ground. A grounding electrode is a conductive object, such as a ground rod, metal water pipe, or ground ring, that is buried in the earth and provides a low impedance path for fault current to flow back to the source. The grounding electrode conductor is a conductor that connects the premises wiring system's grounding busbar or terminal to the grounding electrode. When the generator is connected to the same grounding electrode as the premises wiring system, any fault current from the generator will have a direct path to ground. This helps to quickly trip a circuit breaker or fuse, energizing the circuit and preventing electrical shock. It is important to note that the size of the grounding electrode conductor must be appropriate for the size of the service conductors or the generator conductors, as specified in the National Electrical Code. Proper sizing ensures that the grounding electrode conductor can safely carry the maximum fault current that may occur. To further elaborate on the grounding requirements, let's consider the specific sections of the National Electrical Code that provide guidance on grounding electrode conductors. Section 250.66 outlines the requirements for the size of the grounding electrode conductor for alternating current systems. The size of the grounding electrode conductor is based on the size of the service entrance conductors. For example, if the service entrance conductors are 2/0 American wire gauge copper, the grounding electrode conductor must be at least number 4 American wire gauge copper. Section 250.50 covers the requirements for grounding electrodes. It specifies that all grounding electrodes that are present at a building or structure must be bonded together to form a grounding electrode system. This includes metal water pipes, metal building frames, concrete encased electrodes, and ground rings. Bonding these electrodes together ensures that they are at the same electrical potential, which reduces the risk of voltage differences that could cause electrical shock. Section 250.52 details the types of grounding electrodes that are permitted by the National Electrical Code. These include metal water pipes, metal frames of buildings or structures, concrete encased electrodes, ground rings, and rod and pipe electrodes. Each type of grounding electrode has specific insulation requirements. For example, rod and pipe electrodes must be at least 8 feet in length and must be driven into the ground to a depth of at least 8 feet. Now, let's consider the scenario where you have multiple subpanels in addition to the generator. The grounding requirements for subpanels are also specified in the National Electrical Code. Each subpanel must have a grounding busbar that is connected to the equipment grounding conductors of the circuits that feed the subpanel. The equipment grounding conductors provide path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse. The grounding busbar in the subpanel must also be connected to the main panel's grounding system. This connection can be made using a grounding electrode conductor or an equipment grounding conductor. It is important to ensure that the grounding conductors are properly sized and installed according to the National Electrical Code. Incorrectly sized or installed grounding conductors can compromise the safety of the electrical system. In summary, when wiring a house with a 200 amp service, a generator, and multiple subpanels, the main panel board grounding electrode conductor can be sufficient for the generator if the generator is connected to the premises wiring system through a transfer switch and the grounding electrode conductor for the premises wiring system is connected to the grounding electrode for the generator. This is in accordance with National Electrical Code Section 250.24. C7. It is always recommended to consult with a qualified electrician to ensure that your electrical system is installed in accordance with all applicable codes and regulations. Failure to do so can result in serious safety hazards. Additional considerations for grounding include surge protection. Installing a surge protective device, or SPD, at the main panel can help protect sensitive electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. Surge protective devices are connected to the grounding system and divert surge current to ground, preventing it from damaging equipment. Another important aspect of grounding is the use of ground fault circuit interrupters, or GFCIs. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. GFCIs monitor the current flowing in a circuit and quickly trip if they detect a difference between the outgoing and returning current. This difference indicates that current is leaking to ground, which could be a sign of an electrical shock hazard. The National Electrical Code provides detailed requirements for the installation of GFCIs in Section 210.8. In addition to the National Electrical Code, local codes and regulations may also apply to your electrical installation. It is important to check with your local building department to determine what codes and regulations are in effect in your area. These codes may have additional requirements for grounding, wiring methods, and other aspects of the electrical system. When installing the grounding electrode system, it is important to avoid contact with underground utilities such as gas pipes, water pipes, and communication cables. Before driving ground rods or digging for grounding electrodes, it is recommended to call 811 to have underground utilities located and marked. This will help prevent damage to these utilities and ensure your safety. Furthermore, it's worth noting that the effectiveness of a grounding system can be affected by soil conditions. Soil resistivity is a measure of how well the soil conducts electricity. High soil resistivity can make it more difficult to establish a good ground connection. In areas with high soil resistivity, it may be necessary to use multiple ground rods or other grounding electrodes to achieve an acceptable grounding resistance. The National Electrical Code does not specify a maximum grounding resistance value, but it is generally recommended to have a grounding resistance of 25 ohms or less. Testing the grounding resistance can be done using a ground resistance tester. This device measures the resistance between the grounding electrode and the earth. The grounding resistance should be checked periodically to ensure that the grounding system is functioning properly. To summarize the key points regarding grounding for a 200 amp service with a generator and subpanels: firstly, a separate grounding electrode conductor for the generator is not required if the generator is connected to the premises wiring system through a transfer switch and the grounding electrode conductor for the premises wiring system is connected to the grounding electrode for the generator as per National Electrical Code Section 250.24. C7. Secondly, all grounding electrodes present at a building or structure must be bonded together to form a grounding electrode system, as per National Electrical Code Section 250.50. Thirdly, each subpanel must have a grounding busbar that is connected to the equipment grounding conductors of the circuits that feed the subpanel into the main panel's grounding system. Fourthly, the size of the grounding electrode conductor must be appropriate for the size of the service conductors or the generator conductors, as specified in the National Electrical Code. Fifthly, it is important to consider surge protection and ground fault circuit interrupters to further enhance the safety of the electrical system. Sixthly, always consult with a qualified electrician to ensure that your electrical system is installed in accordance with all applicable codes and regulations. By following these guidelines, you can ensure that your electrical system is properly grounded and safe for use. Remember, electrical work can be dangerous, and it is always best to consult with a professional if you are unsure about any aspect of the installation. The role of the transfer switch extends beyond just preventing backfeed. It also ensures that the generator's neutral conductor is properly handled. In a separately derived system, like a generator, the neutral conductor needs to be bonded to ground at the source, which in this case is the generator. However, it's crucial that this bonding only occurs at one point in the system to prevent circulating currents, which can cause nuisance tripping of circuit breakers and other problems. The transfer switch facilitates this by disconnecting the normal neutral to ground bond when the generator is active, ensuring that the generator's neutral is properly bonded at the generator itself. This single-point bonding is a fundamental principle in electrical system design and is essential for safe and reliable operation. The equipment grounding conductors, often referred to as the green wire or ground wire, play a vital role in providing a low-impedance path for fault current. These conductors are connected to the metal enclosures of electrical equipment and appliances and are bonded back to the grounding busbar in the panel. In the event of a fault, such as a short circuit, the fault current flows through the equipment grounding conductor back to the source, causing a circuit breaker to trip and to energize the circuit. This quick de-energization minimizes the risk of electrical shock and prevents damage to equipment. The equipment grounding conductors must be properly sized according to the National Electrical Code, based on the size of the circuit conductors. Improperly sized equipment grounding conductors can limit the flow of fault current, delaying the tripping of the circuit breaker and increasing the risk of electrical shock. It is also important to ensure that all connections are tight and secure to maintain a low impedance path. The grounding electrode system, which includes ground rods, metal water pipes, and other grounding electrodes, provides a connection to the earth. This connection helps to stabilize the voltage of the electrical system and provides a path for lightning and other transient voltages to dissipate into the earth. The grounding electrode system is connected to the grounding busbar in the panel via the grounding electrode conductor. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in the National Electrical Code. The grounding electrode system should be inspected periodically to ensure that it is in good condition and that the connections are tight and secure. Corrosion and damage to the grounding electrodes can compromise the effectiveness of the grounding system. In addition to the grounding requirements for the generator and subpanels, it is also important to consider the grounding requirements for other electrical equipment in the house, such as lighting fixtures, receptacles, and appliances. All electrical equipment must be properly grounded to ensure safety and prevent electrical shock. The grounding requirements for specific types of equipment are detailed in the National Electrical Code. For example, metal lighting fixtures must be grounded to the building's grounding system. Receptacles must be of the grounding type and must be properly grounded. Appliances with metal enclosures must be grounded. Grounding is a critical aspect of electrical safety, and it is essential to follow all applicable codes and regulations to ensure that your electrical system is properly grounded. When in doubt, consult with a qualified electrician.